Hello, my name is Mitov, the president of Mitov Software, and in this session I will demonstrate creating Internet of Things solutions with Delphi and Arduino. What is Arduino? From the hardware point of view, Arduino is a low-cost, open-source hardware microcontroller board. It is resilient, difficult to damage hardware. There is a huge number of clones of the original board, and new clones are coming literally every day. It is simple to use for hardware designs, and being a microcontroller, it is very good for real-time tasks. From a software point of view, it is a uniform development environment and API that can be used to program multitude of platforms. Originally, Arduino started with a single platform, and as it became popular, other platforms created compatible API and adopted the same uniform software tools. So many Arduino projects can be used with different boards without the necessity of any significant change. Over the years, many boards have adopted Arduino, including Teensy, Edison, Galileo, and even Raspberry Pi and its clones. Here are some examples of Arduino boards and clones. You can see that they can come with variety of sizes, shapes, from items the size of a coin, with just few digital or analog ports, all the way to boards with more than 50 digital I/O pins, as well as boards designed in the shape of robots. Boards designed for variety of specialized shapes, including boards for wearable clothes. Here are even more examples. Some of the boards, like the LinkedIn one, has built-in Wi-Fi as well as GSM connectivity and GPS right within the board. Others require the addition of shields in order to support such functionalities. They are boards designed and ready for industrial control, as well as boards designed for extremely small development. Even some of the small boards, like this one, have the capability of using stackable shields. Why you would use Arduino for Internet of Things? The Arduino boards are usually very cheap. Some of the devices are as cheap as $2 or less. Many of them offer a large number of digital and analog channels. There is a huge number of connectivity options through shields and built-in modules, including Ethernet, Wi-Fi, Bluetooth, GSM, GPRS, and many others. There is a large variety of sizes, starting with as small as a coin, all the way to pound-sized boards. There is also a huge variety of readily available peripherals. The Arduino boards typically have very low power consumption and can operate from battery for long periods of time. The Arduino community provides a uniform Arduino development environment called Arduino IDE. The Arduino IDE is a very minimalistic development environment. It very much simply allows you to edit one fairly simple file using a relatively simple C++ code. Since the Arduino boards do not use real operating system, the code is executed primarily in two sections. There is an initialization section that will be executed when the board is powered up, and then there is a loop section where repeated code will be executed. Very much the simplest code for Arduino is the code to turn on and off an LED. In the Arduino community, this demo is referred as the blink demo. Here is the code necessary to blink an LED. First, we have to configure the digital pin that we want to control as an output pin. Once when we have done that in the setup section, in our loop section, we will set the pin to high, wait 1 second, set it to low, and wait another second. And this loop will keep executing over and over again. Now that we have written the code, it's time to upload it to the board. The Arduino IDE allows you to generate code for a large variety of boards, and you can install more boards. In this case, I will be uploading the code to my Arduino Mega, and I will use the default processor. I also need to select the COM port, which is a virtual COM port over USB connection on which my Arduino is connected. Once this is done, I can generate and upload the code. In the Arduino IDE, there are 2 options. By clicking on this button, I can compile the code, and by clicking on this button, I can compile the code as well as upload it to the board. The code is compiling, and now it's uploaded to the board. This is my Arduino Mega board. It has 2 shields on top of it, an Ethernet shield and a shield for connecting graphical LCD displays. And underneath the shields, you can see that the LED connected to digital pin 13 is flashing once a second. If I want to program another board with the same program, as example, Controlino Maxi, I can select it from the Arduino IDE as a target, select the proper COM port, and upload the very same sketch. Here you can see that the is flashing once a second. All this sounds great. However, once when we start using Arduino, we very soon run into challenges. The development tool, as demonstrated, is very rudimentary and cumbersome to use. When dealing with the hardware, Arduino usually requires relatively low-level programming and careful planning for timing. Most people have no problem connecting hardware to Arduino, but they usually get lost on the programming side. There is practically no debugging at present in Arduino. The only debugging is through print messages over serial port, which is time-consuming, cumbersome, and error-prone. When Arduino is used for collecting data, there is no easy way to visualize the data besides just printing it in a serial terminal. There are no readily available tools to communicate with Arduino from Delphi and C++ Builder. Let's switch to our sketch and take a look at some of those issues. We just saw how we blink LED. We turn it on, wait a while, turn it off, and wait a while. But what if we need to blink 2 LEDs, and each of them blinking at different rate? We cannot use this code because the code is effectively a single thread code. While it is waiting for 1 second here, it cannot do anything else. Yes, in Arduino, you can program interrupts, but that makes it even more complex and requires even more low-level programming. You can also use a complex calculation based on the elapsed microseconds and decide what pin to turn on and off, but even such simple task will take quite a while to accomplish. There has to be a better way. Here is where Visuino comes to play. Visuino is a graphical development environment for Arduino. It automatically generates Arduino code and programs the boards. It has built-in data visualization. It has direct mapping of software and hardware components. It provides uniform communication over serial or socket-based channels, and it includes serial port and socket communications components compatible with Communication Lab for Delphi and C++ Builder. Here is how it all works. Visuino allows you to graphically design your project. Once when you're done, by a click of a button, you can automatically generate Arduino code. The Arduino code will be opened in the Arduino IDE, and from there, as we demonstrated, it can be programmed into a variety of platforms. When you start Visuino, in the central part of the screen will be the editing area. A board component will automatically appear and will always stay there, allowing you to connect other components to the board. On the left top side, there is a navigation screen showing you the overview of the graphical editing area, and below it there is Object Inspector allowing you to edit the currently selected component. On the right side, there is a component toolbar from where you can select and drop components. The components are organized into categories and subcategories. The same component can appear in multiple categories. Below the graphical editing area is the communication panel. In this panel, you can monitor the communication in a text terminal or using scope component. First, we'll create the same Blink application. To do that, we'll need a pulse generator. And we'll connect the pulse generator to pin 13. Our program is ready. Now we can generate the Arduino code. To do that, we'll click on this button. This will generate the code and will start the Arduino IDE. Here is the generated code. Once this is done, we can again compile and program our Arduino board. Our first Visuino project has been completed. If we want another blinking LED with different frequency, all we need to do is drop another pulse generator and connect it to a different pin. Now we can set the blinking frequency for the second LED. As example, 7 times a second. We can even control the frequency with another signal, as example, a sine wave. To control the frequency of the pulse generator, we need to add a pin through visual light binding. To do that, we'll go to the frequency property, click on the pin button and add a sync pin. Then connect the sine generator to the pulse generator. Again, we can generate the code, compile and upload it. We can also add the option to enable or disable each of the pulse generators. Again, we can add a pin through the visual light binding, in this case for the enabled property. And we can do the same for the second pulse generator. And we can connect those pins to appropriate digital pins to control the enable/disable for the pulse generators. You can see how easy it is to create already fairly complex Arduino projects in mere seconds. And again, our code is quickly ready to be uploaded to the board. If, as example, we want to monitor the values in the analog generator from Visuino, we can connect the output of the generator to the serial port, generate the code, compile and upload it, select the port on which the device is connected in Visuino, and connect. You will see that the data arrives in text form from Arduino, and we can monitor it in the scope. In this case, it is a sine wave. In Visuino, you can connect multiple data sources to the serial port. As example, we can monitor what is happening on this pin, or what data arrives from this analog pin. As well as the data from one of the pulse generators. As you can see, we have a mixture of data, and this is very confusing. Visuino offers an easy solution for this problem. We can add a package component The component allows us to add different channels, such as analog channels, digital channels, color channels, and many more. To use the component, we also need to add a unique header marker. We can put any number here. This marker will ensure that we can easily discover the beginning of the packet. Now we can connect the output of the packet component to the serial, connect the pins we had connected before to the corresponding channels of the packet component, disconnect them from the serial port, compile and upload the project. If we switch to the communication panel, we can select the packet component and the communication panel will automatically configure for it. It will add one more tab with instrumentation, and it will add all the necessary channels in our scope component. Now we can connect and monitor the communication. You can see the different channels and the values on them. To make the signal more interesting, I will add another signal generator, in this case a random generator, and I will connect it instead of my external analog pin. If we connect, we'll see the two signals, and now the scope will look more interesting. In addition to the packet communication component, Arduino offers corresponding unpacket component, allowing serial communication between Arduino boards. As we'll see later, we can do exactly the same on the Delphi side and have Arduino to Delphi or C++ Builder communication. Now that you're familiar with the basic communication with Arduino and controlling simple LEDs, let's take a look at some of the other available components and options. A typical component that we often need to control is a stepper motor. We can add a stepper motor by dropping the motor's component, and we can connect all of the pins of the motor at once to corresponding pins on the Arduino board. The stepper motor can be set to enable a certain speed, or we can connect a pin to manually control the stepping. We can also add a sync pin through visual live binding to control the motor, as example, with one of the analog pins. In this case, we'll control its speed. As shown earlier, we can also control the enable-disable of the motor through a digital pin, pulse generator, or any other source of Boolean values. We can also control a servo. It is very easy, as example, to control a servo with potentiometer by just connecting analog input with the corresponding pin of the servo and then selecting which digital pin the servo will control. If, as example, we want to control the servo instead of from analog pin with ultrasonic distance sensor, we can easily add such sensor as well. For this sensor, we'll need to connect two pins, one generating the pin signal and the other receiving the echo, and the measured output now can be connected to control our servo. We can control the servo position by moving our hand above ultrasonic finger. Visuino also offers variety of display options. As example, an LCD display. Visuino offers support for I2C and direct pin displays. All I need to do is drop the display and connect it to the I2C port. I can simply send values to the display, in which case the display will scroll the text, or I can do something more interesting. I can add specific fields, as example, a text field saying value 1, an analog field to display the value. And I can specify on which row and column the field will be positioned. As example, I can say row 10. In this case, the first field will be at column 0, row 0. The second field will be at column 0, row 10. Once that I have done that, I can display the analog value in that field. And I can even specify the precision with which the value will be displayed. If I want to change the board to a different board, I can do that from this button. As example, I can switch to Arduino Mega. Visuino will try to preserve all existing connections, if that is possible. If I switch to some really small board, like the Trinket, Visuino will still attempt its best to preserve the design. And we can quickly make the small remaining necessary changes. In addition, we have a full visual undo, redo functionality. We can see how our design looks at every single point of time, and we can undo and redo to that point. There are many more options to display data than using LED or LCD. The latest version of Visuino includes support even for TV out. And we can draw a variety of shapes on the screen or print text at specific positions. As example, we can add a circle and a text field at specific position and hook the text with one of the analog pins. For the circle's right position, we can also add a sync pin and control it with integer value. As example, from one of the analog pins. Now we can connect a TV set with composite input and we can display a picture on it. Now that you're familiar with Visuino, let's see how we can communicate to it from Delphi and C++ Builder. Here is how Visuino integrates with the rest of the Mitov Software's products. Mitov Software offers Communication Lab for Delphi, C++ Builder, Visual C++, and .NET solutions such as C# and Visual Basic.NET, which allows Arduinos programmed with Visuino to communicate with any of those environments without the need of writing any code. In addition, OpenWire Studio has the same communication capabilities as Visuino, and the two can communicate. We'll start with a new Visuino project. We'll add a sign generator and we'll connect it to the serial port of the Arduino. And we'll program our board. In Delphi, I will create a new VCL form application. I'll add a COM port component and a terminal component. I will connect them in the OpenWire view. I will double-click on the COM port to select the port on which my board is connected, compile, and run the application. You can see the data arriving in my application from Arduino. Now I will reopen our structured communication demo. In Delphi, I will add unpacked component, remove the terminal. In the unpacked component, I'll add two floating point channels and two binary channels. And I will set a header marker at 5555. Then I will connect the two components. To display the data, I will use a scope as well as some gauges. And for the binary channels, some LEDs. I'll add additional channel to the scope and I will connect the analog channels to it, as well as to the two gauges. Finally, the two binary channels into the LEDs. For the two gauges, I will set a maximum value of 1 as the data will have values between 0 and 1. Compile and run. You can see the data arriving in the application. If I want to access the receiving data in my code, I can use generic filters. As example, generic real value. I can connect the corresponding channel and then inside my event I can receive and work with the data. The same functionality is available in C++ Builder. Now that we know how to communicate over serial port, let's change the communication to using sockets. For the Arduino board, I can add an Ethernet shield. First, I need to assign a MAC address to my shield. I will use one from the online demos. Second, I will assign a static IP address so I can easily find my Arduino on the network, and I will enable it. I also will disable DHCP so the static address will be enforced. Finally, I will add a server socket, and I will set a port for the socket. All I need to do is take the output of the packet communication and connect it to the pin of the server socket. I can leave the communication going both to the serial as well as the server socket, or I can disconnect the serial, program, and upload my sketch. In Delphi, to change from serial to socket communication, all I need to do is add a client socket, set the port, the IP address, delete the COM port, and connect my socket to the unpacked component, compile and run the application. You can see the data arriving over the network. Earlier, we mentioned that we have the same communication options inside OpenWire Studio. OpenWire Studio is a graphical development environment for Windows, very similar to Visuino. It has COM port component, terminal component, as well as packet and packet components. And we can use them the same way. We can run in debug mode, where we can monitor the data as it flows between the components, or at run mode, where we can just monitor the visual components. We can also use sockets. Run exactly the same way. Finally, we will look at some other communication options available in Visuino. We can also add Wi-Fi shield or GSM shield. The Wi-Fi shield works very similar to the Ethernet shield, and we can add sockets here too. The GSM shield has packet service, which also allows adding sockets. All of those sockets can be connected, and the data can be sent to all of those channels simultaneously, or the data can be connected to individual channels. Some other boards, such as the LinkedIn LAN, have built-in Wi-Fi and GSM modules. We can add sockets to those the same way. And we can send data through those sockets. Finally, we also have the ESP8266 Wi-Fi module. This module can be connected to a serial port on one side and can have its own sockets. It performs Wi-Fi communication on its own and sends that data to the Arduino board. The Arduino board will directly use the data from the connected sockets. In this case, we can send one of the channels to this socket. You can see that we have a large variety of communication options available both on the Delphi side as well as on the Visuino side. With all of those socket-based communications, we can simply use the client socket component on the Delphi side to receive or send data. This concludes our session. Once again, my name is Bojan Mitov, the president of Mitov Software. My email is mitov@mitov.com. Our website is www.mitov.com, and we offer the following products: VideoLab, a video processing library; AudioLab, audio processing library; SignalLab, digital signal processing library; VisionLab, computer vision library; PlotLab, data visualization library; InstrumentLab, visual instrumentation library; Intelligence Lab, Artificial Intelligence Library; Logic Lab, Boolean Logic Library; Animation Lab, Universal Animation Library; Communication Lab, Serial and Ethernet Communication Library; Visual Live Binding, Universal Visual Live Binding Library; OpenWire Studio, a graphical development environment for Windows; Visuino, a graphical development environment for Arduino. We also maintain some open source libraries, including the OpenWire library and iGDI+, a Delphi-friendly GDI+ library. Thank you for listening, and now it's time for questions and answers.